Okay, now for the more interesting bit, we need the heat, right? What we have going on here is we have our state 1 down there, we have our state 2 over here. We're increasing, right? We're going from, what was it? From 60 to 1300 or so, and we know we're adding heat. Okay, under these conditions, work can be 0, that's okay. Work could go in, which means that the increase here is due to work plus heat, or work could be going out. In our case, we know it's an expansion, so we know this is the situation we have. Okay, so if I need to calculate internal energy from 1 to 2, that's going to give me heat from 1 to 2 plus work from 1 to 2. This is going to tell me that, let me grab the values, I forget. State 2 is 1379, state 1, 6298. Okay. No, not 300, because it's all kilo, so it's like 69.3. It has to be 69.3 because this is in kilojoules per kilogram, right? So therefore, Q1 to 2 needs to be the sum of all of this, sum of heat and work and internal energy, and that gives me 1387.23 kilojoules per kilograms. Okay, so I'm going to keep this to the side because I need to multiply this by 5. But let's first find the Q from 2 to 3 before we do that. And then from 2 to 3, I know 2 is 1300 and I know 3 is 2500, almost 2600. So from 2 to 3, we're again going up in our energy scale. We again have heat going in, but this time we know work is nil, so there's no work going in or out. Okay, so that's super simple. That means that my internal energy from 2 to 3 will be equal to my heat from 2 to 3. And that is the 2599 minus the 1379, which gives me 1220. Beautiful. Now I can combine this with the other one that I have and multiply with the mass to find the total heat. Okay, so total heat is $1385.23 plus 1220, both in kilojoules per kilograms, multiplied by 5 kilograms. So Q total is a big number. Then I'm going to go approximate to 10. 1.3 times 10 to the 4 kilojoules. All right, so about 13 megajoules. Beautiful. All right, with that out of the way, the only thing left for us to do is put the TS diagram in place. So part B asks us, can you please do a TS diagram? And we know the TS diagram has like so. And we're starting out of here because we are a compressed fluid. We're going to hit stops, and then we're going to go like so. Is that about right? Well, I need to check a couple of things. I need to check the temperature first. Okay, so let's go on state number one. State number one. State number one is a compressed fluid. So in our temperature is 15, so 15 Celsius, and about 0.22 for my entropy. State 2, I am a mixture, so I am at 164.95. 164.95 Celsius. And I am a mixture, so I'm going to be around 6. A mixture, right? So sorry, so about 34%, 36% of this. Should I do the math? I wonder if I should do the math here to get the proper number. S2 will be 19918 plus 36.4% times 47153. S2 will be about 3.7. Okay, so 3.7 Alright, and then state 3 is between these two, so my entropy, so my temperature is going to be around 200 and something. Call it 210. And this is going to be around 6.3. So about 210 and 6.3. All right, so in a TS diagram, we have our dome, just like on the PV diagram, and we have our lines for the same pressure that go along this side here, and then they go like so, and then they go, oops, and then they go, and then they go up like so. So from state 1 to state 2, we want to be on these lines because it's the same pressure. It's a 7, so we can call this the 700 kilopascals line. And then we go into we increase our pressure. So we're going to go out of this and into some place here in the middle. Or we go all the way to the end, right? All the way like here to a saturated state. So what we want to do here is state 1, and that's going to be my 15 Celsius. Then state 2, right where it touches, and that's going to be my 164 Celsius. And this is at 0.22. This is at 0.3, no, 0.37, And then I have my 200. And then I have my 200, which is going to be greater. So let me think about this. It has to be here at the end. It has to be at 6.3. It's a saturated vapor, and the pressure cannot be the same as before. So over here, 210. Okay, so that's kind of the gist there. We're going to go from here to here, all on the same pressure line. And then on this pressure line, we're going to change gears, because at this point in time, we're no longer at the same pressure. And we're going to be increasing our pressure and without changing our volume. So we're going to follow this path here until we reach state 3. Okay, so state 1, state 2, state 3. These are in kilojoules per kilograms Kelvin, and this is in degrees Celsius. Beautiful. All right, so that does it for our TS diagram. That does it for this problem. If you have any questions, as per usual, just put them down below in the comment section, and we'll be sure to address them. If this video is useful to you in any way, please consider giving it a like, and we'll talk soon.